All right, welcome to the first of many of our little STAAR review tidbits. Today we're going to start with density. First of all, I want you guys to be familiar with the fact that on the reference materials, on the reference chart that is given to you to use on the STAAR test, you are given the formula for density. Density is equal to mass divided by volume. It's over here just in abbreviations. Now, I'm not sure if you guys have seen this before, but this is kind of a popular trick to help you figure out when to multiply, when to divide, etc. You can draw a triangle, kind of split it right here. The density is going to go right here, because it's going to be mass over volume. Mass over volume. Now, that may be helpful. Obviously, if you need to calculate density, there's the formula. But what if you needed to calculate volume? Well, you would just cover up volume, and the formula for volume would be mass over density, mass divided by density. If you needed to calculate mass for some reason, just cover that up, and the formula becomes density times volume. Okay, so if you're solving for density, put your finger on that, mass divided by volume, which is the formula given. Volume, density divided by mass. Mass would be density times volume. Okay, and you can take advantage of that and do some of that for the other formulas, but we'll get to that later when we talk about speed and force. So we're going to quickly revisit a couple of things about density. Density is the measure of how tightly packed together things are. Basically, there's two things that determine density: the size of the atoms in the object and how closely those atoms are spaced together. Okay, so if you have heavy atoms spaced very closely together, you have a very high density. Okay, and we measure density as a ratio of mass to volume. Okay, so you take your mass, you divide by volume. For instance, if we took this simple box and its mass was 8 and the volume was 4 milliliters, calculating the density would be 8 divided by 4, and it would be 2 grams per milliliter. Each milliliter, in other words, would have a mass of 2 grams. Now, what if I took that box and I cut it in half? Well, what would happen to the density? Well, really nothing. I cut the volume in half, but by making it into 2 pieces, I also cut the mass in half. Okay? So, mass of 1/2 of the cube is only 4. The volume of 1/2 of the cube is only 2. It's half of both of these numbers up here, but when you divide, you still get the same density. So, does size affect density? No. Density is one of your properties of matter. For instance, a big chunk of gold is going to have the same density as a small chunk of gold. Size of the substance does not affect the density of the substance. Okay, without getting into details, these are some kind of graphic examples of things with different densities. The box, the size of the box really kind of represents the volume, and the number of dots represent the number of atoms or the mass. Okay, so for instance, this box and this box, if you look at them carefully, the boxes are the same size, so the volumes are the same, but this one has a whole lot more mass packed into that volume than this one. Okay, so this one has a much, much, much bigger density than this box. Okay, so density is not only mass, but volume. It's a ratio of mass to volume. Okay. This is really closely packed together. Not as closely packed together, but that's still fairly dense. A little bit less dense. These two look like they might have about the same density because this is a small volume and only a little mass. This is a bigger volume and more mass. But if you look, it's about the same compactness. Okay? All right. So let's see if we can calculate density in a couple of examples. Okay, you might want to write these down on a scratch sheet of paper as we do a few of them. Number 1 says a solid rubber stopper has a mass of 33 grams and a volume of 30 cubic centimeters. What is the density? Okay, go back to your little formula sheet and see that the formula for density is mass divided by volume. So what you're going to do is you're going to say 33 divided by 30, and the density of that rubber stopper is 1.1 grams per cubic centimeter. All right, number 2, a chunk of paraffin, which is wax, has a mass of 50.4 grams and a volume of 57.9 cubic centimeters. What is the density of the paraffin? Again, we're finding density. Okay, so here it is on my little STAAR notepad. 50.4 divided by 57.9. And you get 0.87. All right, we're going to skip down to number 5. It says, what is the mass of a pure platinum disc with a volume of 113 cubic centimeters? The density of platinum is 21.4 grams per cubic centimeters. Okay, just give your answer in grams. So this time, we're actually being asked to find mass. So remember, you can cover up mass. Mass is going to be density times volume. So that's 21.4 times 113. Okay, that's going to be in grams, and then divide by 1,000. Okay. Okay, we're going to do one more example. We're going to hop down and do number 8. It says the density of gold is 19.3 grams per cubic centimeter. And what is the volume of a 575 gram bar of pure gold? Okay, so this time you're being asked to find volume. So cover volume up, and that's going to be mass divided by density. Okay, let me clear this. All right, so mass of 575 divided by 19.3, and you get 29.79 for your volume, and your volume is in cubic centimeters. All right, here's one more, and it says an unknown substance has a volume of 6.5 cubic centimeters and a mass of 68.25 grams. Calculate its density and then identify which substance it is likely to be on the table on page 119. Okay, so we'll look at the table, which is right here, in just a minute, but first we've got to calculate its density. Okay, remember that density is going to be mass divided by volume. Okay, density is mass divided by volume. So let's get that set up. All right, so here are my numbers. And let's go to the calculator. 68.25 divided by 6.5. And you get 10.5. All right, so let's write that down. All right, and then we're going to go to the chart that they were talking about. All right, so we got a density of 10.5. And I'm looking, water is 1, iron pyrite 5, looking through. Silver looks to be what I have because silver's density is 10.50. And this is actually what they do if you bring like an unknown piece of jewelry to a jeweler and you want to know whether it's actually real gold or not. What they do is they measure the density. So that's actually pretty helpful. So whatever substance we had, whatever piece of, jewelry or whatnot, we have something that's silver. Okay, so I've just stolen a piece of bread from my son's sandwich to show you guys and make a point about density. So I've got a little digital scale right here, and right now it says 0.0 grams. I have a little piece of bread, and I'm going to put it on the scale, and the piece of bread has a mass of 5.7 grams. Now, I'm not going to measure the volume because that's kind of an irregular shape, but y'all can see that it is a certain size. And I don't know if you guys have ever played with your food before, but if I take this and I mash it all up, I can make it fit into a much, much smaller volume. Okay. But if you notice, the mass hasn't changed. I've just squished it down and I've made it more compact. I've actually made it denser. And now I'm going to eat it.